All right, Mike, I think we're going to get started just because I'm starting to see the numbers and I want to be respectful of everybody's time. Good afternoon, everyone, and welcome to Duke's Pump Station Monitoring Webinar. Really appreciate you taking the time out of your busy schedules to join us today. I head up marketing at Duke's, and I'm honored to introduce our speaker today, Mike Ping. Mike's our National Technical Manager at Duke's and has for over 20 years, has extensive experience in the wastewater industry. He's a licensed engineer in both North Carolina and South Carolina and graduated from Clemson University with a degree in electrical engineering. Mike is married with 5 kids under the age of 17, and he did want me to share that he's 52, and with 5 kids, he is very, very tired. Just a couple of housekeeping. We do encourage you to submit any questions you might have as Mike goes through the material using the Zoom Q&A icon in the lower portion of your screen, not the chat feature. Use the Zoom Q&A and throughout the session, and then we'll address those at the end, and we'll go through those at the end of Mike's presentation. And if we have enough time left, we'll also open it up to any questions you might want to ask live. All we'd ask you to do is just raise your hand in Zoom. We'll unmute your mic and then ask you to ask your question. So with that, please thank you again for joining us today, and join me in welcoming Mike Ping. Thanks, Mike.
Thank you, Mark. Just as an audio check, you can hear me okay?
Yes, we can.
Very good. All right. So while I'm the technical manager, of course, Murphy's Law, my entire workstation shut down about 5 minutes before the top of the hour. So I think we're going to be okay, but I'm on my little laptop here. So yeah, I'm Mike Ping, and we're going to talk here for about 25 minutes or so in regards to pump station monitoring. So the topics will cover kind of what's out there, what systems do we see out there, why does this data even matter, characteristics of ideal data sets, some example scenarios, and then finally, what do we offer into the marketplace? So taking a step back here, some characteristics of modern information flow, just some examples here, what stuff that gets used every day. There's lots of information out there that we all use. Some of it's more critical than others, but there's some characteristics here, and just going to touch on those. Number one is anything that we're touching on a daily basis, it has a simple and easy setup. So one example could be Amazon. You enter a credit card number, 123, boom, you're shopping, and you could spend all of your money, right? So number two, access to data is very quick and easy. And only one tap. Sometimes it's 0 taps. You could set up your mobile device with a home screen with data right there, right? So number three, everything's presented in an understandable format, and the thought of having a training class or multiple days of training classes to set up, any of this information that we use on our personal level, is absurd, of course, right? So number four, legacy or trend data is readily available, and probably most of us, I do, you have your banking information online, and certainly everybody wants to see hopefully that number getting bigger, but if it's getting smaller, you could set up an alert and check it out. So I want to touch on the importance of customized data viewing. So this is a snapshot of my personal phone that I did just a few days ago. And this information structure is unique, for me, of course, right? I've got, hotel details for next week that I was working on earlier this morning, and, things like kids sports app where I need to be run around all weekend, and work email and all that sort of a thing. So, that's my data structure. And everybody listening here, your data structure, probably your phone is set up exactly for you. And if it's not, you rearrange it and make it set up for you. In my case, having an Apple phone, Apple isn't telling me what information is important. I'm the one, I decide and move it around and make it fit for me. So the takeaway here is that I want to portray here is the data accessibility, data presentation slash structure plays an important role in the efficiency of the sharing of information. So getting into pump station monitoring, and I'm just going to tackle this here. We use terms interchangeably. A lot of people you describe it as a lift station or a pump station or lift station monitoring. I'm just going to run forward with pump station monitoring, but we're obviously talking about a pump setup that's pumping wastewater from somewhere out in a collection system, hopefully transporting all of that to the wastewater treatment plant. So what does the average utilities pump station data look like? And it spans the spectrum. And I'm sure a lot of you guys have experience with this, but one could be large Excel files with manually entered data. Seen a lot of that. I can think of a couple utilities off the top of my head that I worked with. It's a person typing things in. There's older radio and landline, a phone line communication. There's that going on still for sure. I can think of another utility that, in their case, they spend over $1,000 per month per site, right, to the local phone company to keep that stuff going. So it's expensive. SCADA coverage on a few, but not all. SCADA, for anybody that does supervisory control and data acquisition, it's kind of sometimes a generic term for just control and data and so forth. Runtime data only. Runtime data is certainly important and could be critical, but it doesn't represent a full comprehensive data set for sure. And then one of my favorites is an overly sophisticated yet with questionable functionality. When I think about that, I'm thinking about the utility with lots of monitors and kind of sometimes refer it as a NASA setup. Lots of monitors, lots of graphics and sauce and glitter and so forth. Which is great, but could doesn't imply that it's necessarily functional. And then certainly there are fully functional systems out there. So we're going to look at this kind of efficiency dial, and I'll start over on the left. That represents kind of the inefficient, insufficient data, difficult to access, and in some cases, going way back, physical data transportation, right? So that's where somebody is, writing something down, they hand it to another human being, that human being transports it from A to B and physically hands it over, right? And then kind of working our way around the wheel here would be a bank teller. I mean, there's information being exchanged in that scenario, and I haven't been through one in many years. When I put this on, it may be 15 years since I've been through a bank teller, but all that stuff's done on a phone app these days. There's mail. We all of course still use mail, but ideally you're working in the green area and it's information that's easy to access. It's quick, it's proactive. There's some kind of notification system, and then a customized presentation. So let's apply pump station monitoring to this scenario here. And one of my favorites is over on the left, again, starting in the red and kind of working our way around would be that's a small pump station that we were working with a utility, and then I ended up kind of scouting some areas out, and I walked up to this one, the exact one in the picture. The control panel was open. If it were raining, rain would be going straight onto the electrical components, right? And the scariest part is the conductors to run the pumps themselves were not even landed, right? So they're like hanging out in open air with the door open. So we're obviously, it's less than ideal, right? Danger, and needless to say, there's no data being transferred. And then a common scenario here, this mess of a workflow up here in the top, kind of the top left part of the page here. That's if you unsure what it is, that's called an electromagnetic flow meter in the red circle. And those are great devices to measure flow. They typically output, an instantaneous flow rate, 100 gallons per minute, for example, and then they have a running total that's behaves no differently than like an odometer in a car, and it may say 5 million gallons if it were installed, 2 years ago or something like that. So, in some cases, and it's prevalent, this isn't connected to any data system. We're talking about physical data transportation, kind of like the old days where somebody hops in their Ford Ranger, they go over there. They may have a laptop, they may have written notes, but they manually enter this data and store it away, and probably, who knows if it ever gets accessed ever again, right? So working our way around the what I'm calling the NASA setup, lots of monitors and graphics and what I, sizzle and sauce and glitter, so to speak. But, in the green over there, look, these, I know of systems where this is a great setup, right? There's field tablets that are dynamically connected, and it's a great setup. But it's possible that those are set up in a static situation where to access the data, you would need to sit down literally at the desk and grab the mouse, poke around, and pull up the data and so forth, right? You could download it, email it. And then, one of my favorites there, it's controlled by the IT department. I know of several instances where I've become friends with the utility guys, and, their system is kind of controlled by the IT group. And in one of those cases, they actually have code writing people on staff, like system integrator type expertise. So, if they want to connect Johnny's new phone over here, they have to get in there and write some code, and, months goes by and all that kind of scenario. Look, it can be good, but ideally you're over there in the green with easy to access, quick, some kind of proactive notification system and a customized presentation. So there's a lot of important pieces of data with a pump station, and a pump station is certainly a critical component in a wastewater collection system. There's, pump status, runtime. Runtime's not it, right? That's a piece of it. Generator, if it's on or off, SSOs, sanitary sewer overflow, force main pressure, electrical pump current, the primary conductors going to the pump, wet well level, and so forth. So what are the characteristics of, ideally functional pump station monitoring? Ideally, at the end of the day, the specific data required to accomplish specific tasks to specific people or persons, or a person, is efficiently and pain-free as possible. And look, every utility is set up differently, but, I think on average, you have some sort of operational component, operational or maintenance component, and have some kind of technical or engineering component that may be inside, that may be, a hired consultant. And then there's some sort of piece of management. So, operations staff maybe are interested. I mean, the obvious, like, or do the pumps even work, right? Or is the power even on? Are there major problems getting some kind of notification? And then the technical / engineering group, their primary concern is centered around the entire wastewater system characteristics in one way or the other. Things like pump curves, or, the pressure of the force main on the discharge side of the pumps, and the, real-time flow rates, and not only weekly totals, or worse, just a monthly total, meaning like, last month we had 50,000 gallons. This month we had, 60. And then it's like, well, did that 10,000 gallons, was that evenly distributed over the month or all at one time, et cetera? Things like energy calculations and so forth. And then utility management, maybe they want to have access to it, maybe just notifications, but, that's kind of generally how it would break up. And then my favorite would be, again, I hope there's no IT specialist on this call, because it sounds like I have something against them. But, there's certainly instances where all the data is roped up and it goes to the IT department off to some place in the name of security, or the Russians are going to get it or something like that. But, the data is really no good unless the people that are running the system have a good access to it. So in summary, different people need different levels of data, no more, no less. And just an obvious example, I mean, you don't want my kid's sports app on your phone, of course, right? So you want the data to be customized for you. Management, probably they no maybe no active data needed. They just want to know, is the system working? Are the tools in place to keep things working? Can they get access to the data should they want it, et cetera? And then the technical piece, things like system performance, pump status, things like maybe digging in and understanding, hey, the force main pressure trend changed. Are the downstream air release valves working? Is there air trapped? The pressure went up, debris, et cetera, things like that. And then on operator and maintenance level, just quick, easy, it needs to be simple to operate, notifications, no training classes, ideally, that sort of thinking. And I want to recognize, I mean, I'm kind of my history in the industry, I've kind of been in a little bit of a business development and some technical and so forth and bounced around. But, I want to be transparent, recognize and acknowledge, there's more than one way to get to good data. There's more than one good way even at that. And probably the most prevalent, method that I've seen is, getting the data through some sort of purchase of hardware. And it's not to say this is like a bad approach or anything like that. It's just to acknowledge, like, what does it require to get from boxes showing up to, a functional system? So, my analogy here, wastewater staff, it's very dependent upon them, making the system work. So there's research involved, a lot of homework. It goes from receiving pallets, a physical installation, right? Learning and programming sort of things like on the instruments themselves. And it's very key to have staff people that are interested, right? Like that's a key piece to it. Then you have you got to operate it in long-term maintenance. Troubleshooting can be complex and require, a lot of effort. Then there's this kind of quote honeymoon period where quite often, the stuff that's new gets a lot of attention. It maybe works great month 0 to month 8 or something. And then, you get out to month 36 or further on out and, maybe the in-house expert left and went to changed positions in the utility and so forth, or went to a different department or whatever, or utility. And then, we always have that threat with other in-house groups, kind of quote, hijacking the system. Excuse me. So what does Duke's offer? Just a high level of overview of what we offer here at Duke. So right out of the gate, the biggest thing is that it's very different and that it's a 100% turnkey service. So there's no hardware purchase. The hardware is included. It's installed, up and running, typically within about 30 days. The cell fees, the maintenance, repairs, I like to say some level of technical support's included. Look, we have an engineering group, and we're not paid like pump guru kind of people, but we certainly can offer some assistance and comment and try to help people move forward, right? So number 3, utility simply logs into a regular website, so there's no software download. It's a web browser, no different than, easiest analogy would be kind of like online banking. The service includes the sensor package. So there's wet well monitoring. There are other things that we'll touch on here, but all of the peripheral sensors are included. The data is online, of course, mobile device friendly. And then number 6, no capital expense. So all the fees are wrapped up and distributed over the long haul. So it doesn't have to be a monthly fee. It can be an annual. It kind of depends on, how the cycle works out. But, we talk about it in terms of monthly fees, and it can be annual or quarter or however it needs to be set up, but it's predictable. So what data points are provided? It's a comprehensive data set, and I would say an advanced data set. So, the wet well level is included, the influent and pump flow rates. So these are calculated values, and if there's an existing instrument there, it's easy to pick that up, and that's something that we can arrange and talk about. The discharge pressure, which is I'm learning is pretty uncommon, but that's certainly a key piece. The pump electrical current, with these values, we can calculate and do the electrical side, the what's called the wire horsepower. Same on the mechanical side, the water horsepower, and with those things like system efficiency, rain gauge data, power monitoring, generator, et cetera. And really, at the end of the day, it's anything with an output signal. But we're in the our Dukes, we're in the wastewater space, so this is built to focus on the wastewater side. So what does quote it look like? So a couple of pictures here on the left. You can see it's a simple little box with some slices of IO, as I like to call it. But this thing gets mounted. Our crews mount it. Typically the utility will have a pump station guy. He's there, kind of checking in with us. But we mount all this, wired up, and so forth. That's what it looks like, and then it has a cellular modem built in, antenna, and you can see here my favorite guy. I'm kind of wearing his picture out here, but he's a wastewater industry vet that retired not too long ago. He was great to work with, but it's turnkey, all inclusive. And one more note on this guy, like you know, he's no young buck. I think he would confess to it since he's retired. And new data systems and so forth can make people apprehensive, right? I like to think like this guy kind of grew up as a maintenance guy in the industry, and I like to think like if he can get his arms around it and is comfortable, then I think just about anybody could be. It's very simple, but again, turnkey, all inclusive of website data support and the alarming and so forth. And another just kind of quick view, I generally like to describe this as like an iPhone generation view. So these things can be moved around. Now, I realize there's an elevated water tank there, and I just got finished stating that we're in the wastewater. Look, a lot of people are water on the distribution side too. And, can this stuff work on a water system? Of course it can. So just to emphasize a couple of things here, everything on the bottom right of the dash line, that represents Duke's responsibility. So all these peripheral sensors, and then just to highlight, the boxes are set up the communication wise with Verizon and AT&T. So there's multiple carriers that provide some redundancy, and then there's Wi-Fi available. We working kind of with one utility that have a citywide Wi-Fi system, and it can transfer the data via Wi-Fi as well. So here's we've kind of focused on the really the backbone of any of this thought process is really like the transfer of information. Excuse me. And in my mind, like alarming and notification is a key component to that. So I like to call this kind of the sequenced alarming. So here, it's just an example here of how it could work. So, we could say like number one, a notification is going to go to an operator if something simple like the wet well level is too high. It exceeded the threshold value. There are three types of alarms. There's what I like to call the FYI. It's just a notification. There's an alarm. Then there's a critical. So it comes in with a status, right? But then that alarm has to be acknowledged within a certain programmable time frame. We can program it to be 5 minutes. We can program it to be 24 hours. It doesn't matter. It's customized for the dynamics within the utility, the specific people and so forth. But if that initial recipient does not acknowledge it, it can go to somebody else. Doesn't have to, but it could go to somebody else. right? It could be a colleague, supervisor, whatever, but we could say like, look, maybe those two guys are out playing golf and nobody acknowledges. They could go to a third tier, a fourth tier, and so on. Any kind of time frame, any kind of logic built in. But it's a very powerful, nice piece of this particular system. And number five there, all of the alarm history is recorded and it's easy to access. So it's good to gain, easy to gain a sense, a quick understanding of kind of historically, like after a year, pulling up like what are all the most common alarms and that sort of thing. So I'm going to go through kind of what I would consider an advanced kind of example. And this was an installation. An engineer was working with a utility and kind of gathering up information. They had some development going on, and at the end of the day, they were going to design and build a new pump station. So we had some stuff so we had one of our setups there gathering data, and he called and he's like, "Look, Mike, something just isn't right." And we've kind of been bouncing back and forth and just couldn't, something didn't feel right about it. So, yeah, I'll wake up one morning and it was still kind of relatively new to us at this point, and just kind of determined to dig in and figure it out myself. And I end up looking at the output pressure. And in this case, this was the pressure sensor was on the downstream side of the check valve. So, I'm digging into this stuff, and I see that the pump's on. The pressure goes up, pumps turn off, and since it's on the discharge side of the check valve, it's seeing the static head. And in those circles, I start to look closer, and it's like it looks like it's going down just a little bit, decreasing, right? And pull that data up in a table and was like, well, it's repeating here. And I'm sure some of you guys know where this is headed, but it's like, that's not good at the end of the day. It's like, on average, this thing is decreasing in units of PSI, start using our what we learned in the water, wastewater, and civil engineering world. There's this 2.31 multiplier, and it's like this thing is losing, 4 feet of static head every cycle that the pumps are off. And what's that mean? That means that the pump flow should be going through the check valve from the station over on the left and being pumped to the right, and this thing is draining backwards. And it was intermittent, which caused more problems because like we did, you pull one data set and it's not happening, and another it is happening. But I just feel like it's an interesting example that you maybe couldn't solve this type of problem with either a simple station with like runtime only type data, and certainly not if the electrical connectors are hanging out in the open air for sure. So in summary here, what we're trying to offer is a simple to implement, easy to access data. Hopefully I've shown that here. It's all critical information. And then, I feel like one of the key pieces is it offers bandwidth within the utility. Being in the industry for more than 20 years, like I'm sure many people listening here have been, lots of friends and lots of contacts and conversations of people within a utility. And I bet nobody on this call has ever had somebody within a utility call them and say, look, we ran out of stuff to do. And, we need to find something to do. We've got extra people here. And, we all know that's not the case. Today, more than ever, people are wearing multiple hats, on the operation side. So this potentially can help in that regard. So it's a good data set. It lowers risk, and ultimately, at least in my mind, it can increase, quote, peace of mind for the people that are responsible for the wastewater system. So I promised about 25 minutes, I think. So I just would like to thank everybody for hanging in there until the end here, especially my computer dying 5 minutes right before we got going here. So hopefully everybody got something out of it. There's some email addresses there. I know some people signed up late that are in different areas, but look, you can reach out to anybody within Dukes. And Mark, I don't know if there have been any questions, but
Yep.
open to any.
Yeah, Mike, did have a question come through for you. Um, how do you measure effluent flow?
Yeah, so the effluent flow is a calculated value. So we begin with the influent flow, and the basis of the influent flow calculation is it's really at the end of the day no different than a drawdown test, right? So there's some calculations, and I'm just going to generally say data scientists working behind the scenes, but that's the core of it. And then when the pumps are on, it's basically using that information to back calculate. And so it's not a direct measurement like a mag meter. And certainly, like I'll say stated here, like it's prone to there are some fundamental limitations. And that limitation, just to state it clearly, would be this, like in fact, like this picture here in the top left at this particular station, it's in a coastal area, and there was a hurricane, and the entire station was underwater, right? So the pumps are spinning, and we kind of the calculations kind of get goofy when that's happening. But like under those extreme circumstances, it kind of didn't matter. We were working with them. We all the information that was needed was had. So hopefully that kind of spells it out. It's a calculated value, and it's pretty good. We've done some testing on that with against mag meters and so forth. So that's what it is.
And Mike, the second one that we got was, can the hardware pick up existing signals?
So it can. So these are all application specific. So we've got one utility that they really had some new nice pump stations, but they had no telemetry. So they had a lot of sensors to pick up, like the seal pressure and seal failures and that sort of thing. Like very easy to pick those up. So yes, it's just something that we would step through if we were to start talking about a specific application. So yes.
Thanks, Mike. Those are all the questions that we had submitted through the Q&A. But we've got enough time that if anyone has had another question as a result of anything that just hit you, or one of the responses Mike just made to those two questions, and you just want to go live and ask that question, just raise your hand, and we'll call on you and take you off of mute, and you can ask your question. Mike, I don't see any hands raised, so
Okay.
looks like you did a good job as
There's a
far
there's a raised hand here.
oh, there's a question, John.
Yeah, I was not a question, Mike. Talking about the versatility of it, would you mind just touching on how the system we had that is extremely sophisticated? Their question was, can they run their SCADA systems through our system? Because they're a massive system, they're extremely sophisticated, but only two people within the organization have
Yeah.
access to that daily information.
Yeah, John. So good question, and I appreciate you pointing that out. I actually wanted to include that. That's sort of along the lines of when I was talking about the NASA setup. So yeah, if there's an existing system that's like custom built, and I can think of like utilities, they get 5, 10 years out, right? So there's a nice infrastructure built. There's a lot of data being collected and a lot of sensing going on, measurements going on. It'd be very easy for us to put our setup on top of that just to make it easier for really anybody, but operators, people in the wastewater group to be able to have access and see that data. So yeah, that's an easy one. So yes, John, thank you.
Okay, I think we got another question from Juan.
Yeah, can you hear me?
Yep, we can hear. Go ahead, Juan.
I'm interested in alternatives to flow metering as opposed to installing AV sensors or, open channel flow meters. So to calculate flow, what are we using? Are we using level sensors to calculate volumetric displacement depending on the size of the wet wells? And if that's the case, then would it be contingent on the levels in the wet well cycling below the invert of the inlet to the wet well?
Yeah, so I heard most of that, Mark. My volume, again, my workstation is maybe dead here, but but I did hear that, and that I can talk about that for a second. So we do AV monitoring, and that's, to be honest, that's the first thing I did when I got into the industry over 20 years ago. So I know that what you're talking about really well, where somebody wants to know a flow rate, and they're tasked with putting an AV, an area velocity type open channel flow meter, just in front of the pump station and a manhole and so forth. And sometimes that's a good option, but sometimes it's not, due to if the station is backing up, the velocity can go low. It can be sometimes it's a very hard, and really it's not a good application for AV metering, in many instances. So yeah, we're calculating it on the difference in the wet well level. So it's really, at its core, it's no different than a drawdown test, right? So it's just like instead of doing a drawdown test and at one point in time and making assumptions throughout, larger periods of time, it's like doing it over and over and over, right? And then it's taking all the historic. I don't want to get into the AI. I personally, I don't think that's kind of qualifies as AI, but it's pretty advanced and refined, and there's a lot of smart people working on it. So, you know, I feel comfortable with it. And to be honest, I think for most applications, it's a number that I would take to the bank. Like, you physically can measure the wet well. We do that when we install it. So it's running a very simple volumetric calculation, dividing it by units of time. So it's all too easy, right? So
Right.
now running and making that run over the long haul and then back calculating pump flow is certainly more advanced, but we like it. We do both. We do AV metering. I've been around thousands of installations, so that's my opinion about it. Hopefully that helps.
Yeah,
Thanks,
so
Juan.
we're using level sensors to count.
So we do. We're measuring yes, we are measuring the wet well level.
Okay.
So we'll drop, both of these in these photos here, they both have wet well levels. So there's conduit. We do it as neat as we can. Everything is different, right? But yeah, there's a pressure transducer going in the wet well, and it's off over to the side, but it's dropped into the wet well. It's a kind of a high-end pressure transducer. Look, we could use any kind of sensor really, but that's what we like to use most of the time.
Thank you.
Thank you, Juan. Any other questions?
Very good. Well, appreciate it.
Thanks, everyone. Have a nice day. Thanks, Mike.